All right, we're going to look at statistics part 2, which is graphical representations of data, and then also those measures of central tendency. Those were the mean, median, and mode. All right, so our first exercise that we're going to be looking at is this frequency table. And you can see that we have a lot of data here. It says that we have data from 20 randomly selected countries, and it's the average life expectancy at birth of women. So I'm going to kind of work through just doing my tally. So 78, that would get me right in there between 77 and 83. 79 would be in the same spot. 49, 77. And you kind of keep going with this. And so I just finished up those tallies, and it looks like, if I look at the frequency here, I have 0, 3 of those, 3, 1, 3. I have 5 plus 3, so that would be 8, and then 2. And then just double checking on here that if you add up all of that, it would end up being, let's see, 10 and 10, that's 20. We get our 20 pieces of data, which is what we started with. So that's just kind of an extra double check for me. And so then we want to talk about the relative frequency. So the fraction of how many are in this category out of 20. So we'll have 0 out of 20, 3 out of 20, 3 out of 20, 1 out of 20, 3 out of 20, 8 out of 20, 2 out of 20. And if you kind of add those all up, you should get 20 out of 20, which is our whole group. In decimal form, 0 is just 0. I'm just going to go all the way across. So that's 0% if you want. Now, if you take 3 and divide by 20, that's going to be 0.15 as a percent. Remember, we read this as 15 hundredths, which is going to be really 15%. Percent really meaning per 100, like a century. So 3 out of 20 again, we'll get 0.15, that's 15 hundredths, which is the same as 15%. 1 divided by 20 is 0.05, which would be 5 hundredths, 5%. We have another 3 out of 20. It's nice when the data is repeated like that. 8 out of 20, we're going to get 0.40, which will be 40 hundredths, 40%. 2 out of 20, 0.1, that's 1/10, which is the same really as 10 hundredths, so that's 10%. And then 20 out of 20, we know that's 1 whole, and that's 100%. If you, again, add up all those percents, it should equal the 100. So to create a frequency histogram, we have all of these already labeled, but we need to define, like, what is this x-axis? This is the actual life expectancy for those female at birth. And this is the frequency that those different categories were happening. And so, again, I already broke it up into ranges here. That's how we're getting this x-axis. So when we look at the bin that was from, let's see, we have 42 to 48. There's just no data there. So we're looking at 49 to 55. There's 3. So I'm looking at 49 to 56 because it starts at 56 there. So I would fill in this whole thing with 3. Between 56 and 62, there's another 3. And then 63 to 69 is 1. So we're only going to have 1 data point there. 3 for the next one. And 8. So I'm all the way up at 8. And 2, back down. And that's our stop. So the question says, in how many countries is the average life expectancy at birth for women at least 77? So 77 is right there. And so we know that there are, above that, we had 8 people in here and 2 in there. And so that would be 10 people have a life expectancy, or 10 countries, that was at least 77. So that means another way to think of at least is greater than. Now it says to explain in words the meaning of the height of the third bar. The third bar is this one right here. And the height of it, we had one country. What that means is that we had one country with female life expectancy between the 63 to 70. Next it says describe in words our shape or the spread of our histogram. And so when we're looking at this, we could say a couple of things. It looks like it is roughly skewed left. And that's because there's like no data, no data, no data, and then it comes over here. And remember that skewed left is because there's nothing going on that left side. So we have that going on. The life expectancy from birth, the range is from 49 up to 91. Which is really 42 years. And then if we want to think about the center or middle of this distribution, kind of evening out, might be helpful to kind of see some numbers here for these stacks. So 3, 3, 3, there was 1. So if we're looking at where the middle data would sit, then there's a total of 20 pieces of data, just kind of looking for the median, middle. I'd say I'd want like about the 10th or so piece, because 20 pieces of data divided by 2 is 10. So we have 3, 3, 1, that's 7, 10. So it's like we're kind of cruising right around here, because then there's another 10 pieces of data on that side that you can see. So around 77 or so, it looks like to be our middle. Okay, and flipping over, it wants us to also find the mean, median, and mode for this data set. So remember, in order to calculate, let's start with just putting the median down. We have to arrange them from littlest to biggest. So if I put down my data points, so those are all my data points written in order from littlest to biggest. Because I had 20 pieces, if I want to find the median, I take that and divide by 2, which gets me really the 10th. So dividing it into 2 halves, 10 and 10. So I need to take the 10th data piece and the 11th in order to find that median. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and 11. So those are our 2 data points. So we're going to add those together and then divide by 2. We're finding really the average of those 2, which puts us at 76.5. So that would be our median. In order to find the mean, we're really just adding up all those data points. So you need to take care of that, add all of them. And then we divide by the total number. So add all data, and then you divide by the total number, which would be 20. And when you do that, you should get 71.3. And then for our mode is what happens the most. That would be, it looks like we have 56 happening twice. We also have 77 happening twice. And that's it. So we'd say that our mode, it's bimodal, 56 and 77 both happen twice. And they appear the most, which isn't very much. It only happens twice each, but it's still going to be our mode. For example number 2, we're going to do that same thing again, little tally, so you can take some time to do that. So when I did that, this is my total frequency. Again, adding them up. This time we had the men, but it's still going to have 20 people are asked. So 11, 12, 13, 14, 15, 16, 17, 20 here. And again, for our fraction, you just write each of the numbers out of 20, which is there. And then if you add those all up, again, we're getting 20 out of 20, which is going to be 1, which is really 100%. That's our goal, making sure we accounted for everyone. Then to convert to decimals, you just divide all of those. So we'll have 0, which I just did, and you should match up with those. And again, you add those up, it should equal 1. And then as percents, we're just really converting all those decimals to percent, scooting over twice, so we get the following percents, which if you were to add all of those, it will equal 100%. And again, we could put this onto our histogram. So we're looking at the, this time it's the average life expectancy at birth of men. And our vertical column, our y-axis, is the frequency that we're seeing here. And so we have 49 to 55, that was our youngest, and that's at 3. Then we get another 3. We have a 1 for those ages. So from 70 on, we get 2. And this time we're up at 7. And then we have 4. So then looking at our next page, a question says, in how many countries is the average life expectancy for men at least 77? So if we go to the 77 again, 77 is right here, and we had 7 people over here and 4 over here, so we had 11. Okay, and that's using the graph to find that information. So there are 11 countries. Explain the words the meaning of the height of the 5th bar. So the 5th bar, so we have 1, 2, 3, 4, 5. That's our 7. So 7 people, and our 7 countries, and that's between 77 and 84. So we're saying that it shows that there are 7 countries with the average life expectancy at birth to be between 77 and 84. Now talking about our, what's the center shape spread of this histogram? Well, it's also roughly left skewed, just like the one that we had for women. And the ranges are still from 49 to 91, which is a range of 42 if you subtract those. And our center still about the same. We're talking about 20 people, so it's still kind of sitting in the middle, around 77, 76, but we can calculate it precisely in a minute. So our center is around 77, 76. And so to calculate them precisely, again, we need to arrange that data from smallest to biggest, which I'll do that. You do it too. So once they're in order, then again, there are 20 pieces in our data set. So if we could go to the 10th and 11th one, 8, 9, 10, and 11, that's these two right here. We have 77 and 78. So if we find their average by adding them together and dividing by 2, we get 77.75 is going to be our median. And our mode, which was the numbers that appeared the most, we have 49 happening twice, 62, 76, and 90. So multimodal here. And then for our mean, if we add up all those data points and divide by 20, you should get 73.05 for that. Again, that's just adding all of those data points up and then dividing by 20. So I think it was like 1461 divided by 20. It should make you have that. All right, so this next part, they gave us some histograms, so it's already done for us, and they want us to kind of talk about the differences between those two things. So one of the things that stands out, first off, just recognizing, is that you can see that typically life expectancy at birth is lower for men than it is for women. So you can see that they went down a lower category. The women didn't get there. So it's about 5 years. Both of them, we'd say, are left skewed. Okay. And so maybe if I want to, so they're both left skewed. Left skewed. And remember that terminology is a little weird because it's actually like all the data is on the right, but that's why it's skewed left. All right, and let's see, what else can we notice? As a reminder, there were 202 countries this time. So if I want to kind of think about the middle, it looks kind of like the middle for women might be still around 70, because you want to see like all the data points on this side is about the total number over here. We can actually write them if that would make you feel a little bit better. But you can see like there's like 4, 1. This would be about 7, maybe 12, 17. And we're trying to get to about halfway to 202, so like 100. And so then maybe again another 12. This one's going up to like 19. Then when we start going really high, all of a sudden there's 30. And then we have like 42 data points up here. Back down to like 27. Again, a 26 or so. And 3. And these are just kind of estimates, kind of looking over here at about how high they are. Not totally precise, but you can see that there are like 40, 50, 60, 70, 80. So there's like almost 100 here. So it looks like our middle would be somewhere between 75 and 78. So I'd put that our center was about 76 for the females. And then similarly for the men, if we kind of think about it, and maybe it would work because we are so left skewed. Let's see how many data points are inside here. Maybe like about 17, 24, 31. This one's maybe 27-ish. Again, I'm trying to get to about 100, so halfway to 202 to see where half my data set is living. And so if I add those up, let's see, that would be 50, 60, 70, 80, 90, really close to 100. So it looks like my middle would be somewhere between 69 and 72. So let's put our center as about 71. And again, these are in years. Good to put our units. And then we can talk about just the spread overall. So for the life expectancy for the females, when we talk about the spread, it's going from 54 to 90, which gives us a range of 36. And for the men, our spread a little bit younger, 51 up to 84, with a range of 33 years. So similar range, but you can see data-wise, it's kind of shifted just a little bit more for the men to the younger ages.